Our next speaker is the President and CEO of Spartan Resources. Please welcome Mr. Lee Barker.
Thank you, Greg, and I'd like to thank the Richmond Club for organizing this presentation for us so that we can give everyone an update on what our company's been doing the last few years and months. We're going to have about a 180-degree switch here from our first presenter talking about organic material and the wellness ability of certain chemicals to make people feel better. And with a name like Barker, I sort of wonder whether oxylunol might be helpful to me myself, seeing that little puppy dog looking so happy on the screen earlier. Spartan is a company that's been around for well over 30 years in its present capacity as a junior exploration company operating in Canada. It's being run and has been run by mining professionals, engineers, lawyers involved in the mining industry, and financial people involved in the mining industry. And myself, my personal background is as a mining engineer geologist. I was involved in the original discovery of the second diamond mine in Canada called Diavik, which you may have heard of. It makes a little bit of press now and again when they have something on TV about it. I actually coined the name Diavik and did the original exploration work that discovered the initial 10 kimberlite pipes on that property. I've been involved with Spartan as a director since 1985. In previous lives with other exploration and mining groups in international and domestic operations, I became a director of Spartan when it was involved in a joint venture with another company that I was involved in called Lacana Mining. The current focus of Spartan since the last, I would say, cycle of commodities has gone from being a junior explorer selling shares for individual projects in Canada to becoming more international. And we became involved in an exploration program in China in 2002 and 3, which was successful for us. We sold it. We made $1 million profit on the sale. And we've actually been cultivating and developing relationships in China to evolve into a producer. We are currently a producer. We've been able to use our relationships that we've developed in China and more recently in Canada to position the company with a number of projects that are on the flyer that I've presented for everybody here that represents what our main focus is now. The last year, we've been restructuring the company to focus on the 4 key elements that we believe can create the biggest value for our shareholders. And we haven't been, because of the situation for junior explorers in Canada and the domestic markets, we haven't been looking at our shares as our currency for raising more money. We've been able to monetize 2 of our projects. We have a captive internal contract drilling company that gives us revenue. We're probably the only company listed on the Toronto Venture Exchange that has a 9 or 10 cent stock right now and has cash flow of about $150,000 a month in revenue. And we're hoping to obviously expand that in the future. What I'm going to do is go through the projects individually for you. We're involved in 4 key commodities. Domestically, in a very large gold exploration program in Northern Ontario with our partner Osisko Mining. Osisko Mining are going to be developing a new mine adjacent to our property holdings, and they actually came to us to option our property to explore it. So I'll go through the different commodities and projects individually, and what I'll do is if you have any questions that come to mind immediately as I'm saying something or you're showing some information, please ask them, because I don't want you to lose the ability at the end of the presentation to have forgotten what you wanted to ask. Are you switching them, Scott, or do I switch them? Okay, just the up and down key?
Yep.
Usual disclaimer, of course, that we're required to put in all these things. Do you want to do that? Okay, because the 4 commodities have different questions, obviously. So. Our gold and silver project, we have divested 2 of our projects this year and monetized them, and we'll be getting almost $1 million in cash, plus we retain royalties on these, and we have shares in the companies that have bought them from us. But our main project right now is a project in Northern Ontario where we have a large land position surrounding Osisko Mining's Hammond Reef Gold Project. Hammond Reef actually will be developed eventually into a 10 million ounce plus gold mine. There are currently 18 drills operating on that property, 2 of which are ours actually. And we're very optimistic that the new work they're going to do on our claims, which will be starting in about 2 weeks' time, is going to result in additional discoveries and create more value for both them and us. We sold our project in the Battle Mountain area of Nevada, which is one of the major areas of gold production in North America, for royalty, cash, and shares in the company that's going to develop it. And we did the same thing on a project that we have in Mexico, a large low-grade bulk tonnage possible silver project. And we're getting revenue, monthly revenue from those projects on the cash payments those companies are making to us. We produce, as an operating mine, a producing operation with cash flow, a metal called germanium. How many people in the room know what germanium is? I can see that very few do. Well, germanium is a specialty metal. It's not a rare earth. It's a rare metal, though. And germanium is surrounding you right here in this room. All of these LED screens that we're seeing with our technology that's doing the IT work for this presentation. Any polyester clothing that you're wearing right now, if there were some water bottles on the table, there would be germanium used in production of those. Your cell phones, the fiber optics cables that bring your data into your office and bring information for your telephone system around, circulated around through our entire social economic system. All of those things use germanium as what we call a doping metal to increase the capacity of whatever the material is to do its work. And germanium has very few producers in the world. A lot of germanium is produced by zinc, byproduct production from companies like Teck-Cominco and Umicore, the large Belgian company. But primary germanium production, the dominant area is in central China, southwestern China. And we actually are the controlling shareholder in a company that's producing germanium from a material that I'll show you in a moment, a specialty coal. And we probably are right now, or will be once we get back to full production, about the 7th largest producer in the world. But we have no peers that you can relate to because there's no other listed companies in the Western markets that are actually doing this. But germanium is a critical metal, and our producing mine is just in the process now of getting a new mining license to allow it to go deeper and increase production. We have a number of opportunities to increase the efficiencies of that operation, to increase the cash flow and the profitability, obviously. And the lower bullet here on the advanced negotiations with a strategic partner, we've actually concluded a negotiation with a private U.S. company called Voltaix LLC, which is the world's largest producer of germane gas, which is a germanium hydrogen compound that's used for high-efficiency solar panels. The use of a germanium layer in a solar panel increases the efficiency from about 15% to over 50% if it's used in the right way. And this company has approached us. They've made an agreement with us as an offtake agreement to buy our product, and they're going to be financing the development of the mine. So this is a major plus for us that we have them as a strategic partner now, and we're very, very grateful.
What money would they be putting up?
They're going to be putting in about $4.5 million over the next probably 18 months. And it's linked to a series of milestones, obviously, as all of these agreements should be, that they put the money in when the goods are delivered by us. And we will be basically delivering to them all of the production from our operations until the initial ore reserve that's defined in the contract is fully exploited. The other metal that we're involved in, and we have a world-class project identified, which we own a portion of now in China again, is vanadium. Now, how many people know what vanadium is in the room? Well, just about the same number. You're surrounded by vanadium as we speak. It's used in structural steel. It keeps your buildings standing because it allows steel to be less brittle, more flexible. And it goes into all your steel rails, it goes into the aircraft that you fly from city to city as a strengthener and a high temperature resistant metal that's used for critical components that hold these things together. And it's a bread and butter metal. It's used to alloy in the iron ore business mainly. But the evolving use of vanadium, is in high capacity storage batteries to allow Mr. McGuinty to make his wind farms more efficient. And if his wind farms become efficient to the extent that you could actually store the energy from these wind farms and use it to feed into the grid in off-peak times, which is what really needs to develop into, the vanadium redox batteries that are being made now in various parts of the world are really the only solution to this problem. There's no other battery system that can be scaled that can actually deliver off-peak capacity for electricity storage and generation from things like solar farms and wind farms. So the vanadium market and the expansion of the vanadium market is very, very likely to evolve through these areas. And also in electric cars. Right now, lithium batteries and conventional storage batteries that are used in cars like the Volt and the Leaf and all these, they work okay, but in the future, a car that's going to compete with a fully petrol-driven, gasoline-driven fossil fuel car is going to have a battery that's going to allow the car to go more than 200 kilometers, that's for sure. And the vanadium batteries that have been designed and prototype tested will be the batteries that will actually ultimately replace these earlier generation of the batteries that are available now. The vanadium batteries are more expensive, but they last longer. And one of the beauties of a vanadium battery is that it can be recharged while it's being discharged, which other batteries cannot. You have to discharge other forms of batteries first, recharge them, waiting, but the vanadium battery can be recharged at the same time that it's being discharged. The batteries can also be recycled by recoring them with the vanadium solution that's used as the main material that actually generates the electricity flow. And so in the future, I believe that over the next 10 to 15 years, we're going to see a huge new demand in vanadium from this area, as long as we're able to continue the development of these electric vehicles and the application of these energy generation technologies. We have a project in China, again, that's come to us through one of our other strategic relationships with one of the large state-owned organizations called the China National Nuclear Corporation. The in situ value of the vanadium in this area is well over $3 billion, and it probably will exceed $5 billion. We've developed the project to the point where we've been appointed the consolidator to put together all the projects in the one area by the local government. And that project right now has gone to the point where we're doing independent technical reports and sort of pre-feasibility evaluations on those projects. And I'll give you details in a moment. The fourth commodity that we're involved in, obviously, is a controversial one, uranium. Uranium goes up and down with the emotional cycles of the newspapers, Fukushima, etc., etc. But uranium is here to stay. I believe everybody in this room knows it. 50% of Ontario's power comes from uranium-powered nuclear power stations. That's not going to change. There's no other place to put it. They're never going to replace the nuclear power stations with wind farms, believe me. And it's here to stay. You have to deal with it. You have to love it. But if you don't love it for various reasons, if you're environmentally concerned, etc., etc., if you want to turn off half the lights, fine, we can turn off half the lights in the room, but it's here to stay. We're involved in a program to extract uranium from waste, which is basically an environmental cleanup program. Believe it or not, between 1965 and 1995 in North America, about 90% of the military-used uranium that was generated in the U.S. Came from waste. It came from burning coal in North Dakota and extracting the uranium from the coal ash, and it came from byproduct production from fertilizer plants in Louisiana and Florida, where they took uranium out of phosphate rock that was used to make phosphate fertilizer. Very few people know that, but in an earlier life in the 70s, I worked for a U.S. company called Pennzoil. I'm sure you've all heard of them. And I actually spent 3 years looking for more sources of this type of material for Pennzoil to develop a uranium extraction program. Because of our experience in China and my background in that particular field, I ended up looking at China as a possible source of waste material that could develop internal production of uranium in China for the Chinese nuclear industry, which is the largest in the world. They're building 60 new reactors, and when they decide they're going to build a reactor in China, they do it. They don't have 15 years of political discussions and changes of government and everything else like we do here. They just get on with it and do it. And our strategic relationship with the China National Nuclear Agency has allowed us to be the only foreign company in the world currently that's allowed to produce uranium in China. And we're targeting basically initially coal ash, which is some certain coals are high in uranium, and the waste coal ash is high in uranium, in fact as high as some uranium mines that produce uranium from primary rock. And this is a cleanup process, basically, so it has an environmental spin to it. It's a recycling process because the cleaned ash can be used for cement. And as an environmentally positive situation, we're getting a lot of support for this from the internal Chinese local governments and the central government. We actually have patented recovery process flow sheets in China using North American technology, which was used historically in the past but has been upgraded. And we actually hold 6 patents in China now for the recovery of uranium from various kinds of waste. And in fact, we were the first foreign company in the resource industry that applied for and was granted a patent in China 3.5 years ago. I'll go through the project highlights in a bit of detail right now. Our gold project in northern Ontario is near the town of Atikokan. If you've ever been to Thunder Bay, it's about a 2-hour drive west of Thunder Bay on Highway 11 towards Fort Frances. Currently, Osisko Mining are developing a over 10 million ounce gold deposit there. We did our own exploration program 2 years ago when I picked up the claim block from the local prospectors. When there was a transition between the ownership of the Osisko property and an earlier explorer, and there was kind of a lack of motivation in terms of the market. It was 2009. The market was tough because of all our world economic problems. And we picked this property up on fairly good terms. We did our own work on it. We made 4 or 5 new discoveries on it. And after we announced all that and did our initial drilling, the Osisko company basically came to us and they agreed to option all of our claims, which almost surround them. Their deposit is on this star right here. It's called Hammond Reef. They've already released a press release. CDAR filed 7 million ounce resource roughly, but that resource is based on work only up until the end of 2009. They've had 2 years of drilling since then. They've drilled about 300,000 meters. They had as many as 20 drills operating there last year. It was the largest exploration project in North America. And this resource will go to more than 10 million ounces, I guarantee it, even though I can't speak for Osisko. I'm sure it will. Our land holdings are in pink here. We have made new discoveries here, here, and here, and actually another one here. And there's a small discovery over here. And Osisko are going to be drilling our claims here sometime in the next 2 or 3 weeks. They'll begin down in this area here. We had some drill intersections in our own work that were similar, but not quite as good as the work that was done previously on the original Hammond Reef deposit. So we're quite optimistic that new work will give us some positive news.
How do you compare with the no at this point with Osisko?
Well, what we have basically is very similar rocks, very similar alteration, and we have wide zones of low-grade gold mineralization. The average grade of the Hammond Reef deposit, depending on what you use for a cutoff, if you know what cutoff grade means, the lower economic limit that you can mine at, is around 0.9 ounces per 0.9 grams per ton. This is similar to many of the low-grade gold mines in Nevada and other parts of the world that are being developed as these large bulk tonnage operations. And one of our drill holes gave us, I believe, around 40 meters of 0.8 grams, so not dissimilar to Osisko. And we're hoping that the Osisko deposit is quite unique, actually, as a gold deposit in Canada. It's not well understood from an academic standpoint. It will be, I'm sure, once it goes in production and people start doing research on it. And this is one of the reasons why it was ignored as a major gold resource in Ontario, because everybody thought it was too low grade. And it was actually this area, this big lakes here and all this water is actually artificial water I see a lot of gray hair here, and people may have remembered that there were two very large iron mines in this area in the 1940s and up till 1975 called Steep Rock and K-Land. And interestingly, I actually visited the Steep Rock mine in 1962 when I was a student working for the government in this area. But all this is artificial water which was dammed up and let the Seine River system back up into this area because the iron ore mines were developed down in here, and they had, of course, obviously keep the pits drained and keep the water out. So it's a traditional mining area, even though now it's mostly fishing and recreation. But they will succeed in developing this. I believe is the largest gold mine in Ontario. And
you still retain a direct interest, or?
We have a 30% interest in this. The Cisco will be spending about $14 million over the next 3.5 years to earn a 70% interest, and we retain a 30% participating interest. And that's dilutable, of course. It's a standard joint venture, but if they make a significant discovery anywhere in this new work, obviously it'll benefit us, and it'll make it easier for us to raise the money to continue to participate. Right now, as I said earlier, they're going to begin a drilling program, we hope, in about 2 weeks' time. They're waiting for a small water permit to cross a creek to actually access this particular site. And that application went in almost a month ago, and they're expecting it almost every day now. Here's the summary of the deal. As I said, they're spending $12 million additional to what they're spending this year. This year's budget was $1.2. They're actually buying $1 million worth of Spartan shares. They have warrants for additional shares at 40 cents, which obviously aren't in the money. But as a real benefit to Spartan, I mentioned we have a captive drilling company, and we, in fact, our little drilling company with 2 small rigs, is doing what's known as condemnation drilling for Osisko. We're drilling all the sites where they plan to build the infrastructure for the mine. And we have a 25,000 meter drill contract with them, which we expect will be expanded by an additional 10,000 meters, and that's a $4 million contract. And we have our equipment is operating there as we speak, and it'll be there for at least 1 more year. And that brings us in revenue of about $150,000 a month. So it basically keeps the doors open. Our profit margin is around 20-25% on that. And that relationship with Osisko has been very positive with us, obviously. We are, in fact, out of 5 drilling contractors, we're their most productive, even though we're the smallest. But we have good people. We have good people as management of the company, and we have good people that work for us as our drillers. To go on from Osisko to the germanium mining operation, it's under the name of a company called Huajun. The Huajun acquisition was initiated in 2007. We concluded an agreement in 2008. As you know, the market fell apart in 2008. Interestingly, because the zinc market fell apart, the price of germanium went from about $800 a kilogram up to $1,500 because there was a huge shortage because the zinc producers weren't producing any zinc, so there was no byproduct germanium available. So the local market was very, very strong until it became saturated in 2009, and the price went back down again. The market has since recovered. It's come back now. The current price for germanium metal is about $1,600 a kilo, and we're in the process now of getting a new mining license. These RMBs here, you divide by 6.5 to get dollars. But our new mining license, we're expected in about a month, and we'll go back into production. We have over 40 tons of germanium metal in reserves, and our new strategic partner, Voltaics, as I said earlier, will be responsible for paying for the development costs of reactivating the production, and we'll be selling them our product as long as the operation has the ore reserve base to sustain that.
Again, it'd be 50-50 with them?
No, the agreement basically is it has a pricing structure that's based on 2 things. One, the costs, and we reconcile that every month according to the formula. Number 2, every quarter, what we do is we do a test sale in the local market to determine what the local price is, and we can reconcile the price they pay. If the price goes up, they have to pay a bit more for the product they're going to receive. And the agreement states categorically that at no time will the mine operate at a loss. And basically, after all that is said and done, it's a 70% profit margin for them, 30% for us. But it doesn't cost us anything, so it's basically a free ride. We have over 400 people operating on this site under full production. And there are 3 small mines that were consolidated together. They're underground mines. This is the wood that's used for the underground ground support or rock support. It's being replaced with metal this year. And the 3 mines are about 1.5 kilometers between all 3 of them. And they were consolidated because of the central government in China's new policies of shutting down all these small mines or trying to consolidate them into one operator, which makes them much more efficient and safer, obviously. And there's never been a lost time or a lost life accident at any of these mines in the last 7 years. And we've passed all the safety tests and done all the upgrades necessary. There are 3 mines here. This one is called Chuanzong, this one's called Wenhua, this one out here is called Defu. And when the 2 mines here were joined underground, this is when the government said you have to consolidate. And the coal seams that we mine and burn to produce the germanium concentrate are basically at surface along here, and they come down at about 55 degrees, dipping in this direction. And so this is the new area of the new ore reserves that will be developed, plus we'll be mining material left behind earlier as well. With the price increase, of course, in germanium, which is nearly double what it was when we acquired this project, we'll be able to mine a lot of the material left behind earlier that wasn't economic for the previous operators. Vanadium. I told you what it was earlier. If you remember, it's used in technology applications, it's used in battery applications, and maybe it'll save Mr. McGinty's wind power project with Sumitomo. Well, the vanadium batteries that I mentioned earlier can be made in sizes sort of twice as big as this room, but they have a liquid core. That's the issue with them. And that liquid core can be regenerated, it can be replaced in the future, but they're not the kind of thing that you put into an airplane and do rolls and dips and turbulence, because the material will slosh around inside. But as a portion of a battery system for cars, I can show you information if anybody's interested enough on the technical side that the vanadium battery is about 200 times more efficient than the lithium ion batteries. And it's just a question of cost, and I believe in the future they will take over. We formed a private company to have a pure play on this last February, which is a subsidiary of Spartan, called Vanspar Mining. Vanadium, Spartan, sort of, mnemonic, whatever. Right now, 75% of that company is controlled by Spartan, the parent, the listed company here on the TSX. 19% is controlled by a private investor based out of the British Virgin Islands that's managed by a very, very well-known and successful mining entrepreneur, a geologist who's been involved in several discoveries worth several $1 billion. For those of you here who are familiar with the mining industry, a uranium project in a company called Uramin was sold to the French 3 or 4 years ago for $2.5 billion, and the gentleman that controls Alpha Prime actually is the founder of that project. And management owns about 6% of Vanspar. In fact, management owns about 6% of Spartan as well, to answer that question if it comes up later. Projects in south central China, in Jiangxi province. We're less than 2 hours by road from major markets. A town called Nanchang, which is a major steel producing area. 2 new 4-lane highways have been built from the 2 major towns to the project, and we're in the west part of the province here. This red line represents a large geological basin of rocks that contain the formations that contain the vanadium. The vanadium is close to surface. It's in layers in a black shale. I'll show you a photograph in a moment. But very inexpensive to mine by open pit methods, and very low stripping ratio. I'm sure you all understand that it costs the same to mine a ton of waste as it does to mine a ton of ore. And we've done a study on this deposit, a series of deposits, and after 20 years the stripping ratio is only 4-to-1. So everything is very close to surface, and mining costs very, very low. This is what the material looks like. It's a shale-hosted formation. There are 3 horizons in some parts of it, 2 horizons in others. This is one particular section that was sampled at surface where there's 5 meters of 0.83% vanadium, and I'll show you some comparisons with other people in the vanadium business in a moment. This is the shutdown plant that exists in this area that a former local businessman tried to develop a vanadium production business from. He employed out-of-date technology, environmentally unfriendly technology, and he tried to operate it himself, and he has absolutely no process engineering background. He built this plant, ran it for 3 months, produced a small amount of vanadium oxide, ran out of working capital, and he shut it down. It's available as a distressed asset, and part of our business plan to develop VanSpar is to acquire this and convert it to a new processing technology which we've actually developed ourselves and patented in China again, and bring it back into production. And this has a very small actually production capacity of about 800 to 1,000 tons of vanadium oxide a year, but that value of that material is around $20 million. And the cost to buy this, put it back into production, convert it, etc., along with the ore reserve that's tied to it, will be less than 12 million. So it pays itself back in about 14 months. This is a look at the deposit. There's a wild card in this deposit. There are significant amounts of zinc, silver, and copper in it, which no one recognized previously until we came into the picture here. And right now we're doing some test work to see if we can extract that in advance of taking out the vanadium to create some added value to the products. And in fact, if we can get even 70% of this out of the rock before we take the vanadium out, it'll pay for all the costs in advance of the vanadium extraction. So we're optimistic that'll be a real added bonus to the project overall. This is a comparison of our grade and our ore reserves in the next couple of slides, comparing our deposits with a number of other companies that are listed companies that are in the vanadium field. The leader up here is Largo, which has a different kind of deposit in Brazil of bringing into production. They have a grade of around 1.2%, but we have assays of over 2% of some of our material at surface, even though our average grade is around 1%. There are 2 other companies that you may have heard of. Sino Vanadium has a project in China. It's the only other one that's got a listed vehicle tied to it. Energizer has a project in Madagascar, large stripping ratio, indeterminate metallurgical work, and lower grade. American Vanadium down here with their project in Nevada, which has been making a lot of news lately and has been financed by Dundee and some other groups here in Toronto. Their grade is less than 1/3 of ours. Their advantage is that it's in North America, of course, so they have a market to go to, and they're going to heap leach this, or they think they will, without having to put it through actually a process, physical process plant. They're going to crush it, stack it on surface, dribble acid on it like you do in the heap leach gold mine, and hopefully get the vanadium out. And they're doing a lot of advanced test work on that now, and have put out a pre-feasibility economic assessment report.
So you mean you're going to create their own pad?
Yeah, they'll build leach pads just like you do for gold mines, and they'll sprinkle sulfuric acid on it. And interestingly, the deposits that we have access to here in China, one of which we control, the other 2 we're in the process of negotiating buying, about 25% of the material there is also oxidized and is amenable to heap leaching. And we've done a drilling program of our own, plus there's over 120 drill holes in this little area that we're working in. Good documented, high quality work done by the Chinese and by ourselves. And there is an opportunity for us to heap leach a portion of the deposit as well. But the silver and the zinc and the copper have been leached out by surface weathering in that material. So,
has anybody done any feasibility studies?
well, we're working on one right now, but we can't finish it till we finish our lab testing. But there is actually a feasibility study just been released by American Vanadium. I have a copy of it. It's on CDAR now, I believe. It basically refers to previous work by previous operators on this deposit in Nevada, and there's still a few holes in it that need to be resolved before they'll confirm that they can actually make it work, I believe. This is where we sit in terms of reserves. Our reserves are at the top end of the scale here because they're virtually unlimited. You drill a hole in this formation, those 3 layers underlie the entire 5,000 square kilometers of the county, and you can get another intersection. But obviously the reserves that are exploitable are the ones that are close to surface, that are cheap and have very low stripping ratios. But we do have well over, we believe, 500,000 tons of contained vanadium oxide in these deposits. At $7 a pound, that's $3.5 billion. So this is a serious opportunity, and we're treating it that way, obviously, with our priorities. This is the highlights of the project. As I said, we formed a new subsidiary last February to have a pure vanadium play. We actually have 4 projects in that county that we're evaluating. 3 of them are very high priority. 4 of them actually have mining licenses, but 1 of them is an underground mine, high cost, steeply dipping. We're not really interested in that. And we have the exclusive right to acquire that plant on a negotiated price basis. We've developed our own clean technology to recover the uranium, or the vanadium. And the other thing here is there's no waste, because once this material is processed, the local cement factory wants every ton of it that we can give them to mix in with their cement production. So we have no necessity to have big waste piles and permitting of waste material and all the environmental implications that brings. As I said earlier, we have low-cost open pit mining. Our mining costs will likely be between $1 and $2 a ton, and a low stripping ratio for at least 20 years because the things are close to surface and they're flat lying. And as I said in that last graph, we believe there's at least 500,000 tons of contained vanadium oxide in these deposits that's exploitable and readily accessible. We have a mandate from the local government because we've put together the best presentation for them for vanadium development in their area to consolidate all these projects. And they're not going to give any new permits to anybody until we've actually got our situation resolved once our final due diligence is completed. Infrastructure is in place. There's power, there's water, there's lots of labor available. It is a poor area. It was originally the largest cotton producing area in China. The cotton market and the demographics of cotton production around the world changed markedly about 10 years ago. So this area actually is welcoming new investment. There's no restriction on vanadium in China for export. China must import over 30% of what they need, so they don't restrict anybody from developing it internally. And there's no surtaxes or anything like that for foreigners involved in it. It's on the encouraged list of resource material for foreign investment. And again, we're in the heart of the world's largest vanadium market. Steel industry. China has more steel production than anybody in the world. They're the biggest market for vanadium. They get most of it from Russia and South Africa right now, and they have some internal production as well. And we believe we have the potential to probably cover up another 10 or 15% of China's total production by developing these opportunities ourselves. Our uranium program, which is, as I said earlier, is a secondary program. It's not from primary uranium deposits. It's a cleanup and uranium production from waste. We have it in a separate company, much like Vanspar, called Spartan Energy. That is it's a pure play. And we have a joint venture with the China National Nuclear Corporation and an MOU with the Lafarge Cement Company to take the waste after we've taken the uranium out. It's a 70% Spartan, 30% China National Nuclear Corporation Group joint venture. We're at the pilot plant stage, and we expect to have our initial production in the same area where the germanium mine is, because that coal, which is used for the germanium production, is also very high in uranium. And in fact, some of the waste piles from that production have up to 0.5% uranium in them, which is the very, very high grade, as good as some of the large uranium mines mining from primary uranium deposits in other parts of the world. These waste piles near the germanium producers are relatively small in terms of overall grade, but they produced uranium from these in the past in China. There were 4 sites where they recovered uranium from waste in the 1970s. And of course in 1982, as you all know, we had 3 Mile Island, then we had Chernobyl. The uranium market went in the tank, and until about 20 years later, there was really no opportunities available for people to develop new uranium reserves. There's lots of uranium in the world, but there was actually production from this area historically, so we know it can be done. We've refined the technology and patented it so we can make it more efficient. And around China itself, there's more than 500 coal-fired power stations, all with very large fly ash piles, and many of these are radioactive because they burn radioactive coal. We also have a joint venture with another group, part of the National Nuclear Corporation, to recover uranium from tailings from their uranium mines. Historically, the recoveries were only around 60-65%. As you know, China worked on 5-year plans. As long as the people operating the things met their targets, they were happy. They didn't try to make anything better or more productive. And this particular tailings pile here has a grade of about 0.05 to 0.06% uranium oxide, which is worth around $300 to $500 a ton. It's actually worth more than the original operation uranium value was when it went into production. So we have all these opportunities available to us. The Lafarge Cement Company is interested in getting the waste after we clean the uranium out and is doing an MOU with us. They're the largest cement company in the world, as you know. And in fact, in the province that this is located in, Lafarge has 18 cement plants and generate 50% of the foreign GDP generated in that province. So they're going to be a very strong partner for us and give us very strong credentials with the local governments as well. We're going to hopefully finance now and build a portable bulk test facility on truck trailers that can be moved from site to site. And we'll take this material, we'll put it through the process, we'll refine the process so we can build a commercial plant, and then we can move this on to the next site and test the next batch of material. Oh, I'm going to do escape, sorry. So that's the end of the presentation for those 4 key commodities. I'd welcome any more questions, and of course, thank you for your attention.